Liz Gaines here from GigaOm with Mike Leopold of the Institute for the Future. He just spoke today on our GigaOm Pro Bunker Series panel about geolocation. And you put out a challenge to the audience, which was we should really get location information down to the millimeter so we can overlay for the purposes of augmented reality. How realistic? I know you're at the Institute for the Future, but how realistic do you think that is?
Well, I think it's very realistic, but it takes a huge scale of processing to make it happen. To get the kind of precision we need for augmented reality, you just can't get there with GPS or even fusing GPS data and Wi-Fi location data. And I think the only way to get there is by actually matching photographs or images with a reference database, the way that Google is doing with Google Goggles.
So you mentioned that, but I thought you were saying it more in the context of this is really scary, but you really think that that's the way to do it.
Well, I'm saying it's scary because anybody else who wants to get in that business has got a formidable competitor. And we had a room full of entrepreneurs. And Google has got tremendous assets, tremendous resources, and tremendous talent to make it happen. But the way it works is that if you were to see the Golden Gate Bridge, you would take an image of the Golden Gate Bridge and then compare it against millions of other photographs until you found one that says, well, this is the Golden Gate Bridge. And from the pattern match of your photograph and the reference photograph, you can determine with great precision the exact location of the focal plane view for augmented reality, and including even the tilt or the pitch and yaw of the image plane.
Even including the incredible zoom lenses?
Sure, absolutely, yeah.
So the idea would be that there would be a complete model of the world understood from the vantage point of every photograph by which it was composited.
Yeah, the model would be as complete as the photographic database of the world.
And then when you take a new photo, it's understood where you are because that matches a previous photo.
Well, yes, and it's going to become even easier because modern cameras will all include geocoding capability. So we'll start to begin to build a global database of geocoded photographs that will make the fine-grained recognition and positioning for AR a lot easier to do. And there are people already building very, very fine-grained reference databases. There's a company right here in Berkeley called EarthMine that's driving around capturing 3D images where every pixel has a URI or URL, and every pixel is accurate within millimeters in 3 dimensions. So that's an excellent reference database for the kinds of augmented reality positioning I was talking about.
Fantastic. So when will we see that?
Well, we're seeing the very, very crude prototypes now. I mean, Google Goggles is showing a few things. They've got some demo apps of recognizing the Golden Gate Bridge.
Right, or the Eiffel Tower, right?
Yeah, Eiffel Tower. And so, in a couple of years, it'll be a little more prevalent. I think it's going to take quite a while. Maybe 5, 6 years. 8. Some people are predicting 8 to 10 years. I'm not sure. It's really hard to tell how long it's going to take Google to do things because they have, as I said, infinite resources, infinite talent, and very, very high quality understanding of the problem.
Could you talk just a little bit about the opportunity that would enable to have that level of accuracy? What kind of applications would you be really looking forward to?
Well, I think we can view a future of a self-explanatory world where everything we see, every building, every object, every decorative detail, every person's face is able to be identified. And even mechanical objects might have schematics or diagrams or help systems that are visible. So the world will amplify our ability to interact with it. So as we just move physically through the world, everything will become richer and more nuanced and better understood.
All right, thank you.
My pleasure.